This problem, section 1.2, number 17. I did it in class today, August 31st, during our work session, but I had paused the recording and I forgot to start recording again. So that's why it's all completed, because I did it, but I paused the recording. So I'm recording it again. I'm just gonna go look. This is what I did earlier. All of this, you see, I'm about to do it again. But I'm gonna erase what I did earlier because I want it to make sense to you if this is your first time looking at it. Let me make sure I wrote down. Oh wait, the problem is different. I'm so confused. Why is it different? I'm quite confused. Okay, I'm just gonna take a moment and write down this problem. I don't know why I must have. Oh, I think, you know what? I think I bet you this was from my other class. I bet you. I'm gonna pause and find this one. That was from my other class. So this is the problem. This one right here. And but it is the same method as the problem that I just showed you. I'm gonna erase what I did here. I just wanted to kind of give you like an overview, just a quick overview of what it looks like. So I'm gonna erase everything and then just start from the beginning. All right, we have a clean slate now, and we're asked to find the limit of this function as y approaches 5, and just notice that if you did plug in 5 for y, you'd end up with 0 in the denominator. So that means that we need to do some work to not get 0 in the denominator. And in this case, we have what's called a complex fraction. And a complex fraction is any fraction that has a fraction in it. So it's a fraction with a fraction. Or it could be multiple fractions, like in this case. In its numerator and or denominator. That's a complex fraction. And the process that I like to use to get rid of complex fractions, there are a couple of processes, but what I like to do is this right here. To simplify complex fractions, multiply by the denominators, specifically the denominators that make the fraction complex. So here's what I mean. So here we are, we're with a complex fraction. That means we have fractions within the fraction. And what you want to do is multiply by what I'm circling right now, the denominators that make this fraction complex. So the denominators of the fractions that are within the fractions, that's what you're going to multiply by. So I'll rewrite what we have. So we have limit as y approaches 5 of 1 over y plus 9 minus 1 over 14 all over y minus 5. And I'm giving myself some room now to the right because I know I'm going to be multiplying by those denominators, y plus 9 times 14. And then whatever you do to the top of a fraction, you have to do to the bottom. So that's why I'm putting the y plus 9 times 14 on the bottom also. And now I'm going to distribute all of this to my numerator. So I end up with the limit as y approaches 5. I'm going to turn on captions. Oh. All right, so wait, I thought I turned on fractions captions. Hold on, I'm going to pause the recording. All right, I just turned on captions. So I forget what I was saying, but we're going to distribute the y plus 9 times 14 to the numerator. So the denominators, I mean, I got that y plus 9 and that 14 from these denominators here. So now I'm going to distribute, and oftentimes I don't write down everything that I'm about to write right now, but so I'm writing it now just to make sure that it's all clear, but it is very messy. It is quite messy. So first I distribute the y plus 9 times 14 to the 1 over y plus 9. And I get y plus 9 times 14. And then this is minus, and now I'm distributing it to the 1 over 14. So I have y plus 9 times 14. So I get that for I have to distribute it to both of them, right? And in the denominator, I'm just leaving things as they are. And the reason I distribute that y plus 9 times 14 to the numerator is because I want to get rid of my fractions. And if I multiply 1 over y plus 9 times y plus 9 over 14, think of this as being like over 1. Notice the y plus 9s cancel. And so I'm just left with 14 times 1. And over 1, which you don't have to write, right? It's just really, I'm just left with 14. 14 times 1 over 1 is just 14. And then I do the same thing with my other term, 1 over 14 times y plus 9 times 14. Like, I recognize that this is just the same thing as being over 1, and then I can cancel out my 14s, and I recognize that I'm just left with a y plus 9. And then my denominator, I don't really do anything to just yet. And then from here, I'm gonna distribute my negative sign. So this negative will get distributed. And so I'll end up with the limit as y approaches 5 of 14, and then distributing that negative, it's like a -1. So it's like -1 times y is -1y, and then -1 times +9 is -9. And then in my denominator, I have y minus, this is just the same thing, y minus 5 times y plus 9 times 14. And from here, I notice I have some like terms, 14 minus 9. So I'm going to go ahead and combine those. So limit as y approaches 5 of y minus 5. I'm just putting my denominator there because I know I'm not doing anything to it just yet. And in my numerator, I have negative y, and then 14 minus 9 is a positive 5, right? 14, I'll put that in blue. It's a positive 5, 14 minus 9. So I have negative y plus 5. And this is actually the opposite of what I need. Like, notice that it was the y minus 5 that was giving us 0 in the denominator if we did plug in 5 for y. And the whole point of simplifying is to be able to, like, hopefully cancel out the whatever was giving us 0 in the denominator. And in my numerator, I have a minus y plus 5 versus in the denominator, what was giving me the 0 in the denominator is a y minus 5. So notice the numerator is just the opposite of the denominator. They're opposites of each other. So, and I want them to be exactly the same. So what I'm going to do in order to make them exactly the same is I'm going to, and you're allowed to just do anything to a fraction as long as you do it to both the numerator and the denominator. So what I'm going to do is I'm going to multiply both my numerator and my denominator by -1. And what that will do for me, if I distribute this -1 in my numerator, what that's going to do is it'll give me the limit as y approaches 5 of, so I'm just keeping my denominator as is. It's messy, but I'm just going to leave it until I've canceled out what I want to cancel out. But my numerator, I'm going to distribute that -1. So I say -1 times -y. That's a positive y because a negative times negative is positive. And then -1 times +5 is a -5 because negative times positive is negative. And now I'm able to cancel out that y minus 5. Yay. And I'm left with just like an invisible 1. Really just left with like a 1 here that we don't see. And so now I have the limit as y approaches 5 of 1 over y plus 9 times 14 times -1. And now I can plug in my 5 for y, and I won't have 0 in the denominator anymore. So now I don't have to write limit anymore. Once you plug in, you don't have to write limit. And this ends up being, did I write it down here? No, that's a different problem, isn't it? Let me get rid of this. So this ends up being 1 over 14 times 14 times -1. And that's how we end up getting the answer of 1 over -196. 14 times 14 is 196. And then times -1 gives us this 1 over -196. Oh, so that's what the answer I got. I'm gonna just do a similar one just for people who were in class and might want to see another one. So let's do another one. And I'll pause this while I put everything together and hope I remember to press record again. Okay, so I'm gonna just go through this much more quickly. So I notice my denominators that are making, first of all, I should say, I do notice that if I plug in 8 for A, I get 0 in my denominator. So I can't just plug in right away. So I'm going to simplify this complex fraction, and I'm just noticing that the denominators that are making this complex are the a plus 7 and the 15. So that's what I'm going to multiply these by. So I'll have a plus 7 times 15. Oops, cancel. Over the same thing, a plus 7 times 15. So I have limit as a approaches 8. And then that a plus 7 times 15 gets distributed. If you feel comfortable doing it in your head, do it in your head. So now I'm able to cancel some stuff out. The a plus 7s cancel out here, and the 15s cancel out here. And so I'm left with this. Just a 15 for the first term, and then minus 1 times a plus 7 for the second term. And now I'm going to distribute that minus. combine like terms. Notice that I'm not able to cancel out the a minus 8 yet because in my numerator, I don't have exactly a minus 8. I have the opposite of what I need, a negative a and a positive 8, whereas I need a positive a and a negative 8. So just a little note here. I want, in my numerator, I want a minus 8, but I actually have negative a plus 8. So to get what I want, I'm going to multiply by -1. And I have to also multiply the denominator by that to get the same thing. I mean, to not change the value of the fraction, I should say, not get the same thing. But I do want to get the same expression in my numerator as in my denominator. So now when I distribute my -1, I'll have -1 times negative a, which is positive a, and -1 times 8, which is negative 8. And then in my denominator, this. And now I'm able to cancel out my a minus 8, recognizing that there's a 1 here that we don't typically write, but I'm writing it now to make it clear that what I'm left with now is the limit as a approaches 8 of 1 over a plus 7 times 15 times -1. And now I'll go ahead and plug my 8 in for a because I no longer have 0 in the denominator when I do that. So now when I plug in, I get 8 plus 7, 1 over 8 plus 7 times 15 times -1, which ends up being 1 over 15 times 15 times -1, which ends up being 1 over 225, negative 225, I should say. And that's that one. And I will just check my answer. 1 over negative 225. There we go. So I hope that helps. Take care. Bye.